Now let's talk about the power property and negative exponents. So the power property, I believe, is one of the most simple properties. With just some examples, you have to be a little more careful. All right, but basically it is this: if I take an exponential expression, which means a base and an exponent, if I take an exponential expression and I raise it to another exponent, so it's like it's a base, an exponent, and then all of that contained to another exponent. If I do that, I can actually just keep the base and multiply the exponent, and it'll be the same value. So let's see how that works. So for example, if I have 5 to the 4th and I square that number, my result is 390,625. All right, now I said you could multiply the exponents and simplify it. So 5 to the 4th squared is really just 5 to the 8th. And notice the value of 5 to the 8th is, again, 390,625. All right, so again, you multiply the exponents. That's the power property. Here's how it works with some expressions. A squared to the 7th, a to the 14th. B to the 4th to the negative 3rd, you get b to the negative 12th, which, by the way, needs to be simplified to 1 over b to the 12th. That's our next topic. All right. And here's a tricky one, right? If I have 5 multiplied to 3b to the 4th cubed, then it's important to go with order of operations here. So parentheses, and parentheses and exponents, right? So I'm going to want to cube 3b to the 4th. Notice the 5 is not being cubed. It's outside of those parentheses. So the cube only applies to 3b to the 4th. All right. So this means 3b to the 4th means I'm going to cube my 3 and I'm going to cube my b to the 4th. So b to the 4th cubed is going to be b to the 12th because 4 times 3 is 12. All right. And again, 3 is just going to be cubed. 3 cubed is 27. And we already simplified to b to the 12th. So we end up having 5 times 27 b to the 12th, and we get 135 b to the 12th. Pretty cool. Okay, so that is how the power property works. And we have one more. So we have negative exponents. Okay, so the golden rule for negative exponents is that they're garbage. You cannot have a negative exponent in a simplified expression. All right, it is not considered under the umbrella term simplified. So whenever you are doing some work and you end up at a negative exponent, I want you to understand that the negative in the exponent basically is an instruction. It's an instruction that indicates you need to find the reciprocal of what would have been the positive exponential expression. So a to the negative 9th is actually 1 over a to the 9th, all right? Because the reciprocal of a number is 1 divided by that number, all right? What if we already have a fraction? Okay, so 10b squared over 2b to the 7th. Well, 10 divided by 2 is just 5, so don't get caught up with your numbers. Just divide them and multiply them the same way that you usually do. But b squared over b to the 7th, all right? So normally that would be, okay, so I need to take 7 away from 2, so that's b to the 2 minus 7th, which is b to the negative 5th. Well, again, b to the negative 5th is not simplified, so it needs to move to the other end of the fraction. In other words, to the reciprocal end of the fraction, the denominator. So this is 5 over b to the 5th. The last thing I want to say about this is you can subtract both ways, all right? If you want to subtract to say b to the 2 minus 7, well, then you're indicating you're keeping it in the numerator, and you get b to the negative 5th. You could also say, if I can just copy this problem, right? If you wish, you could say, well, first of all, I got 5, but I'm going to keep the b at the bottom. So I'm going to say b to the 7 minus 2, all right? Because I'm keeping it at the bottom. So that final result, b 7 minus 2 is 5, so you get b to the 5th. And in that case, you didn't run into any negative exponents. So a wise man once told me, a negative exponent means, move me, all right? As annoying as that sounds, all right? But a negative exponent basically indicates a reciprocal, all right? Which means it needs to be moved to the other end of the fraction. That's how negative exponents work. So I hope that was clear, and make sure you do all of your practice, all of your work. Happy learning.